Hi everyone, my name's Matt and I bought a Steam machine in 2024. If you don't know, back in the mid-2010s, Gaben and the boys over at Steam decided they wanted to try and capture some of the console gaming market by creating gaming PCs that offered a console-like experience. Valve would create the operating system called SteamOS, and partners like Gigabyte, Main Gear, and Alienware would create hardware to run SteamOS, which would be dubbed as Steam machines. These Steam machines, along with the controller and the Steam Link streaming box, were all launched in November of 2015, generating very underwhelming sales. And while this project was very short-lived and somewhat of a failure, Valve was able to take a lot of the ideas and technologies and use them years later down the line for the Steam Deck that was released in 2022 and has been much more successful. While these old Steam machines weren't ever very practical, I can remember seeing them back in the day and thinking they were super cool, and that even if I couldn't justify buying one at the time, I would still love to own one in the future. Well, fast forward to a few weeks ago, I found one of the Alienware Alpha Steam machines on eBay for only $40 plus shipping, so I decided to say what the heck and purchased it along with an original Steam controller and a Steam Link to see what these old console replacement PC products were all about. But there was one slight problem. Fully working ones were still going for hundreds of dollars, and to get one this cheap, I had to buy one that was listed for parts and that would probably take a little bit of work to get back up and running. Opening up the Steam machine's box, I found it packed decently well in some brown paper and paper towels. The only thing included were the system itself and the power adapter. My first impression was this was a pretty darn small system at around 200 by 200 millimeters or about 8 by 8 inches. On first glance, it was definitely a little dirty, but overall looked to be in good shape. The one thing I noticed on the underside was a pretty big buildup of dust in the cracks, and while I wasn't ready to open this guy up just yet, that definitely had me worried about how the inside would look. So I hooked up power, HDMI, and some peripherals. Turning the machine on resulted in no video output, and the power light blinking yellow in a series of 5 blinks at a time. This is a pretty common and well-known issue that from my understanding was a sign of a dead or dying CMOS battery, and because it wasn't booting, it meant it was in fact time to open it up. Removing 4 screws at the bottom allowed me to pull off the bottom panel, and the top panel could then just be lifted away to reveal a pretty dusty interior. I pulled out the CPU and GPU fans to try and find the CMOS battery, but couldn't find it. After doing some research online, I learned the CMOS battery is very conveniently placed on the bottom of the motherboard, requiring a basically full teardown. So I unscrewed and removed the hard drive, then took out the 4 motherboard screws, unscrewed and removed the back I/O panel, and then lifted up the motherboard tray, revealing the CMOS battery. It was secured with double-sided tape and connected to the motherboard with a 2-pin connector. To test if the battery was actually bad, I grabbed my multimeter to measure the battery's voltage. Probing the 2 pins, I found the battery was reading at under 2 volts, which for comparison, a new battery of the same type gives about 3.3 volts. This meant the battery was definitely going to need to be replaced. Now I could have bought a $5 replacement off Amazon that included a new connector and everything, but I have a bunch of these 2032 button cell batteries on hand, so I decided to try and modify the existing connector to fit a new battery. I cut open the plastic covering and tore off the 2 contact points on the old battery, then I electrical taped both contacts to a new one and wrapped it up in more electrical tape. Testing those contact points again now showed the battery cell was giving off the appropriate 3.3 volts, so then I plugged in and taped down the new battery. I plugged the PC back in, thought I was in the clear, then it started blinking yellow again, which I realized that to reset everything I needed to unplug the battery, hold in the power button for 60 seconds, let the PC sit for 20 minutes, and then I could plug the battery back in, plug the system back into power, and this time when I booted it up, the light thankfully stayed blue, meaning the CMOS problem had been corrected. And after switching out the HDMI cable, I finally had display out. I booted to the Windows image that was installed, which I assume was the previous owner's, and this is a good reminder to anyone watching this to make sure to wipe or remove any drives from a system you're selling, even if you think the system is dead. Now I'm gonna clean up and upgrade the system so we can see its full potential, but I figured let's install a fresh copy of Windows first on it and see how it performs in its current configuration. Speaking of the current configuration, it's time to talk about the PC itself and its specs. Now, being 100% truthful, this is the Alienware Steam machine, but it also isn't. See, because the Steam machine concept was so unsuccessful, Companies like Alienware took their Steam Machine hardware and sold versions with Windows pre-installed instead, which is what I have here. The only difference is this came originally with Windows 8 instead of SteamOS. It would have originally come with an Xbox controller instead of a Steam one, and this bottom illuminated piece right here would have had a Steam logo. But other than those minor things, this is the exact same hardware, including CPU, GPU, case, and all that was used for the Alienware Steam Machine. In terms of specs, this is the base model that retailed for $450 and came with an Intel Core i3-4130T, so a 4th gen Intel CPU with 2 cores, 4 threads, and a frequency of 2.9 GHz. The CPU released all the way back in 2013 and is socketed into the board, so it is upgradable. The GPU used is, from my understanding, basically an NVIDIA GTX 860M, which was a mid-range laptop GPU released in 2014. It is 2 GB of video memory and is found in all levels of the version 1 Alienware Steam Machine and Alpha. For RAM, this originally came with a single 4GB stick of DDR3 memory, but at some point the previous owner also added an extra 8GB stick for 12 total, which is another reminder this is pretty old hardware, as it's kind of crazy to think of a gaming system shipping with 4GB of RAM. For storage, this used a 500GB thin 2.5-inch hard drive, and it's all wrapped up in this console-like enclosure. For I/O, it has the power input, dual HDMI, SPDIF audio, Gigabit Ethernet, and 4 USB ports, 2 USB 3 at the back, and 2 USB 2 at the front. Also, while I am going to wait to upgrade most of the parts, I did switch out the hard drive for a 1TB SATA SSD from the get-go just to make initial testing a bit faster. So I did a fresh install of Windows 10, which I'll be using for my main tests, but we will try and install SteamOS 3 on this later in the video. I honestly had no idea if this machine would be able to run pretty much anything modern, especially with only 12GB of RAM, a dual-core i3, and 2GB of video memory, but I fired up a few games to get some initial data. I started with Rainbow Six using the built-in benchmark. I tested this machine at 1080p with the low preset. Doing this resulted in a honestly pretty solid 63 FPS average with 1% lows of 44. This was good to see it above 60 FPS, but again, this is just Rainbow Six and isn't very hard to run. Next, I upped the difficulty by running Borderlands 3 at 1080p very low settings using the built-in benchmark. This resulted in a 36 FPS average with 1% lows of 25. This is definitely on the edge of playable, so I hopped into a game to see what kind of experience it would give me, and yes, it was a bit stuttery, but overall this gave a surprisingly playable experience, which definitely had me excited to see how it would perform after some upgrades. Finally, for the heck of it, I decided to test Cyberpunk 2077, but I knew this would struggle, so I set it to 720p low and fired up the built-in benchmark. Doing this resulted in a 31 FPS average with 1% lows of 19, which honestly was surprising. It gave above 30 FPS. In game, it definitely wasn't what I would consider playable, but it also didn't crash or anything, so again, maybe after a CPU upgrade, Cyberpunk will be playable. Also, temps weren't that bad, with the CPU and GPU both never going above the mid-70s, and the machine was a little noisy, but I don't think I would consider it obnoxious. So now it's time to clean the machine up and throw in a couple upgrades. I started by fully tearing the system down, removing everything except for the CPU so that I could clean each part individually. Now I wasn't super thorough, I just used some 99% isopropyl alcohol along with a toothbrush and some paper towel to quickly clean everything up. The one part I used a different method on was the fans, which I just used a toothbrush and vacuum on. This got most of the dust out, and while they're not perfect, they definitely look and should perform a bit better. With everything cleaned up a bit, it was time to throw in the upgrades and put this Steam machine back together. The first upgrade was already made, which was changing the mechanical drive for a 1TB SATA SSD. The second upgrade was to take out the old i3-4130T and replace it with an i7-4765T, which is a 4-core 8-thread CPU that can turbo up to 3 GHz. And if you're wondering, this machine requires a 35-watt TDP CPU, so something like a 4790K is out of the question. This upgraded i7 should provide nearly twice as much multi-threaded performance, but on a single core basis it should be basically the same. After installing that, putting some thermal paste on and resecuring the cooler, I next applied and spread out thermal paste on the GPU die and reinstalled its cooler. Once that was done, I could move on to the final upgrade, which was installing a 16GB kit of dual channel DDR3 memory. This is a kit I had on hand from Team Group that should work nicely in this build. With the upgrades in, I could then just fully reassemble the system and load back into Windows to see what kind of performance I would get. Firstly, going back into Rainbow Six at 1080p low, I did see a minor increase to 66 FPS average and 48 for the 1% lows, which was an increase from the original 63 and 44 I got earlier, but was less of an increase than I expected. Borderlands 3 was a similar story, with the average going from 36 to 37 and 1% lows going from 25 to 29, so again, pretty marginal improvements. Cyberpunk was even more the same, with both the average and 1% lows increasing by only 1 each, so going from 31 to 32 for the average and 19 to 20 for the 1% lows. I honestly expected a little more performance out of these upgrades, but looking at most of the benchmarks, even before the CPU and RAM upgrades, showed the GPU was in a lot of cases the limiting factor. With that being said, even though this machine really isn't great for modern gaming, just going around Windows and doing basic productivity was perfectly fine. Now, originally paired with the Steam machine would have been the Steam controller, which I had to buy separate on eBay. It runs on AA batteries that have a pretty neat eject function, and this has a dongle that plugs into a dedicated USB port on the bottom of the Steam machine. This controller features all the normal controller buttons you'd expect, but instead of a right joystick and D-pad, the Steam controller has dual trackpads, making navigating the OS and playing PC games theoretically easier. In addition to these, there's also 2 buttons on the back sides of the hand grips. Along with this controller, Valve released the Steam Input Configurator, which allowed you to customize the buttons and inputs on the controller to fit your exact playstyle and liking. This is a pretty neat and well thought out controller, and while I think it is very good for navigating around Windows, in game I kinda just found it a little awkward and honestly much prefer just a standard Xbox controller. With that being said, I am happy I was able to get my hands on one and play around with it, as I've always been curious about what they were like to use. After the upgrades and testing out the controller, I decided to see if I could install SteamOS 3 on the system, which is what comes on the Steam Deck. I tried to install it via Nabara, but just couldn't get it to work. See, even though Nvidia support was recently added to SteamOS, as far as I can tell, it's only really for more modern Nvidia GPUs, and this weird 860M just wasn't supported, which was disappointing. Now there's one more product to talk about which released at the same time as the Steam machines did, which is the Steam Link streaming box. This $50 box allowed you to stream your PC games directly to your TV, and it works pretty darn good even in 2024, but it does only support 1080p, so if you already had a PC, it made no sense to get a Steam machine, when for $400 less you could just get this Steam Link box, and in many cases have a better gaming experience. So all in all, for modern gaming, the Alienware Steam machine just doesn't really seem to be worth it. Now for general Windows use, it's absolutely fine and could even probably be used as a retro games console. With that being said, this all got me wondering what a modern Steam machine would look like, and now I kind of want to build one with a custom case. So if you'd like to see me try and build a modern interpretation of a Steam machine and install SteamOS 3 on it, let me know in the comments below. Also, let me know what you think of this little Steam machine and if you think Valve should bring them back. So yeah guys, I think this wraps this video up. I may make a follow-up video about the Steam machine if there's enough interest, but for now I think I'm done playing around with it. I hope you guys enjoyed this video. If you did, give it a thumbs up and consider subscribing. And as always, this is Matt from Tech by Matt, signing out.